This is Bri Murray, and I want to welcome you to another episode of Doc Bri, the Physics Guy. Hi everyone. I've always been a really big fan of James Bond. I think I've probably seen every single film, some of them multiple times. They always used to be on at Christmas. I used to watch the first ones with Sean Connery, and this was the days before the internet, where the only place you got to watch them was on the cinema or the TV, as I say, usually around about Christmas. And one of the ones that sticks with me is Diamonds Are Forever, partly because Shirley Bassey sang the Bond theme that year. Diamonds are made out of carbon, and this post is on carbon, the material from which diamonds are made. That always struck me as a bit odd. The hardest known substance and the stuff of life turn out to be the same thing. Graphene, the wonder material, is also made out of carbon. It really is the element that just keeps giving, eh? Anyway, what has this got to do with physics? Well, the question today is, where did the carbon come from? And how did physics enable this discovery to take place? Current thinking says the following. Carbon is probably created by the triple alpha process. I say probably because, like many things in physics, we have no real way to test it. But it makes sense in a way, and it's the best theory we have. It was discovered by an astrophysicist, Fred Hoyle, a bloke from Yorkshire, England. He was also the guy who named the Big Bang the Big Bang. His thinking when it came to carbon was something like this. We are here and we're made of carbon, so carbon must have originated somehow. The only physically conceivable way is through the triple alpha process. He then went on to make predictions about the nature of carbon should this process be true. And lo and behold, it turned out to be correct. Now, there's an interesting story attached to this that I've not been able to verify. The story is that up until this discovery, Fred had been a full-on atheist, a non-believer in God. But this process seemed so unlikely to him that he couldn't shake the belief that there must have been some guiding hand at work. Physics turned an atheist into a believer. Which is odd in a way, because most people try to use physics to disprove God, or at least the need for God. And in Fred's case, it brought him to God. So, the triple alpha process, what is it? Helium is the second element in the periodic table, and it's a gas. It's the one that makes your voice go all squeaky. Its nucleus is made up of 2 protons and 2 neutrons. The centre of the helium atom is called the alpha particle. The reason it's called the alpha particle dates back to the early work on radioactivity. Around the 1900s, a physicist called Rutherford had managed to separate radiation into 3 types, alpha, beta and gamma rays, and it was based on how the mysterious rays penetrated objects and caused ionisation. It was later realised that the alpha particle was actually the helium nucleus. It took 7 years for Rutherford to prove that, but he did it, 7 whole years of work. And since that time, the helium nucleus has been known as the alpha particle. The triple alpha process is where 3 helium nuclei join together to create a single nucleus consisting of 6 protons and 6 neutrons, which is carbon. Okay, big deal, you might be thinking. Well, it is, because without it, for one thing, we wouldn't be here. The triple alpha process is actually a 2-stage process. 2 alpha particles join together to create a beryllium nucleus, and then a 3rd alpha particle bashes into the beryllium particle to create carbon. The problem here though is that the beryllium particle formed from the 2 alpha particles bashing into each other is very unstable. I mean seriously unstable, and it disintegrates back into 2 alpha particles almost immediately. So this means that the conditions for creating carbon must be fairly specific, and it turns out that they're far more specific than you can possibly imagine. This tells us something about the way carbon-based life must have evolved. The triple alpha process requires high temperatures and pressures if it's correct, and this means that carbon could not have existed shortly after the Big Bang, while the temperatures required to create carbon exist for a very short time after the Big Bang. The alpha particles and the pressure required didn't, so there was no carbon produced during the initial Big Bang. So if the Big Bang model is true, then the universe was completely devoid of carbon-based life for literally billions of years after its creation. We had to wait for stars to go through the process of creating helium and literally growing old and dying. Young stars are made out of hydrogen. It's the fuel of the star. As it burns, it doesn't literally burn, but as it's used up, the hydrogen nucleus join together to form helium, giving out energy in the process. Eventually, after millions or billions of years, the star begins to run short of hydrogen. When the star runs short of hydrogen, it starts to collapse and the pressure and temperature inside the star increases. When the temperature and pressure increase within the star, the helium centres begin to react with one another, creating beryllium. And while this form of beryllium is massively unstable, it sometimes survives long enough to react with a third alpha particle to create carbon. And carbon, once it's made, is really stable, even when it's inside a star. Eventually, the star dies and it can do one of several things. It can either go supernova, so it explodes, and the carbon along with other elements created in the star are blasted out into space as dust. Supernova are mind-blowing, including the timescales involved. A star can last for billions of years. Our own star is expected to live for about 10 billion years. When it goes through its final stage, everything happens not in years or even hours. The final stage of a star's life happens in seconds. When the star reaches a point where it doesn't have the fuel left to stop itself collapsing, it does so in a truly spectacular fashion. Stars go out with a bang, an almighty bang. A star implodes at a fantastic rate before exploding, sending out the star's material into the universe. There is some evidence to show that during a short interval, a supernova can radiate as much energy as the sun is expected to emit over its entire lifespan of 10 billion years. This is one of those statements that may be true, but just doesn't make any sense to us. It's impossible for us to imagine how much energy our sun produces in a single second. It's impossible for us to imagine timescales longer than a typical human life, say 100 years. Try imagining 500 years, it's not really possible, so 10 billion years is just a number. To take the amount of energy that's produced in that time is beyond comprehension, and multiplying it by that time scale is way beyond comprehension. It delivers numbers that are just beyond our imagination. It's just truly, truly massive. To try and put it in some perspective, the supernova would glow so brightly that it would be brighter than an entire galaxy. And this can last for weeks or even months. One thing that's really cool though, and check this out, is that as the star collapses, the first thing to escape are neutrinos, and this is because they fail to interact with pretty much everything. Light gets trapped for a short while, and that gives the neutrinos a head start. The neutrinos appear to travel pretty much at the speed of light, and so it's likely, if this theory is correct, that we would detect the neutrinos before seeing the light. There is some hope that Betelgeuse, a star in the constellation of Orion, may go pop in the next few years. We've no real evidence for this, that it's going to go anytime soon, but it's been acting really oddly, and so there's hope that it might implode and go supernova within our lifetime. This would just be super cool. Partly because if the theories are correct, then there would be a real chance that it would glow in the sky as bright as the moon, potentially for months. Imagine that. Once a star has exploded and thrown out all the stellar dust, we currently think that somehow the stellar dust starts to stick together, forming larger particles that then become small rocks. The rocks join other rocks to become asteroids, the asteroids hit other asteroids, and we become bigger and bigger and bigger, and eventually, in some cases, they form solid planets. The exact mechanism for planet formation isn't understood. In the case of our planet, the carbon created in stars enabled the creation of life, and this for me is one of the greatest things about life and carbon. Life on Earth is based on carbon. Carbon comes from stars. Each and every human being is made from the carbon made in stars. We really are made from stars. How cool is that? This is Dr. Bry, the physics guy. Hey everyone, this is Dr. Bry, the physics guy. I hope you enjoyed this episode. If you did, Can you share it with your friends, your fellow students, and anyone you think might be interested? That'd be great, and you'd be doing me a massive favour. Subscribe now so that you don't miss out on the latest episodes and news, and check out my website right now at drbry.com. That's drbry.com. And for a limited time, I'm giving away the first part of my 7 ingredients course. It's absolutely free. There's almost 40 minutes of free video explaining the course and why you have what it takes to do physics and how it can change your life forever. And there's also a free download that you can keep. All the details are on my website. I'm also on YouTube, Instagram and Facebook, and all the details are there on drbry.com. drbry.com. I look forward to seeing you soon.